In the previous videos, we went over Carey's analysis of male and female falcons. We were interested in wing length. We're doing a t-test with equal variances assumed for the male and female falcons. And now we're going to do the same thing in this next series of videos, except we're going to assume unequal variances for the male and female falcons. And so we'll begin with data generation in this video, and also in this video we'll do the frequentist analysis. So when we generated data previously, the scenario with equal variances, we use this matrix model. In this case, for unequal variances, just to show that there's different ways to skin a cat, what we're going to do is a different kind of code. You see here, to generate data for two populations with unequal variances. It's perhaps a little bit simpler. We're going to say, okay, N1 is 60, that's the number of males. N2 is 40, that's the number of females. And then we specify the means for the two populations. Mu1, 105, mean for the males. Mu2, 77.5, mean for the females. And then we specify, and again, we're dealing with unequal variances. So the sigma 1, the standard deviation, is 3 for the males. Sigma 2, 2.5, is the standard deviation for the females. And then we're going to generate our data using these two lines here. So we're going to say Y1. So Y1 is going to be, that's going to be for the males. And how are we going to get those values? We're going to take N1 equals 60 observations. So we're going to get 60 observations from a normal distribution with mean equal to mu1 equal to 105 and standard deviation equal to sigma 1, which is 3. And then we're going to repeat the same thing for the females, except now we're going to have 40 observations taken from a normal distribution, independently taken from that distribution. And each one of those observations is going to come from a distribution with a mean of mu2, 77.5, and a standard deviation sigma 2, 2.5. And then we're going to combine those two. So right now all we've got is this variable y that's got these 60 male wing lengths and these 40 female wing lengths. And then we're going to create a new variable called sex. And here's the code to do that. We're going to use the repeat function. We're going to have male and female. And how many times are we going to repeat the character male? How many times are we going to repeat the character female? We're going to repeat the character male N1 or 60 times. And we're going to repeat the character female 40 times. So now we're going to have sex, which is simply a character vector that is male, male, ... female, female. And then we're going to combine all this. Combine all that to make a data frame shown here. It simply combines y and sex. So there's the data frame, and there's the structure of the data frame that shows we've got these two variables, a character, 60 values of male followed by 40 values of female, and a numeric, which is the 60 wing lengths of the male followed by the 40 wing lengths of the female. And then what we often want to do is make a histogram, and you can see that here. And you notice that not only do the males have greater wing lengths, but also there's more variability in the wing lengths for the males than there is for the females. So, having done all that, now we're actually going to do some analysis, and we're going to use the program GLS, and there's the code for it, and you can see the output is shown here. So what do we have? This value here represents the intercept, which in this case the female is the reference, so that's the female wing length. This value here, sex male, is the difference between males and females. So if you add this value to this value, that gives you the male wing length. So in terms of the variance, we're going to use, I'm not sure why this happens, but it appears for the variance or the standard deviation, we're going to use the male as the reference. We're going to give that a value of 1.000. And down here you've got what the standard deviation is. Now, as it says in your notes, this is really a mistake. This should be standard deviation, but it shows up as standard error. And then in terms of the female, in terms of standard deviation for the females, that's got a factor of 0.8326. So if we take the 0.8326 and multiply it by this value here, the 3.027, that will give you the standard deviation of the females.